Hello students, welcome back to the 8th video. This is the last video of this playlist. So in this video, we will be solving question number 8, the last question from Statistics 1 January 2024 paper. So let's see what's the last question of this paper is about. So basically the concepts behind question number 8, it is very specific. That is, it is specifically from normal distribution. That is the last chapter of your Statistics 1 book. So for this question, to understand the solution of this question, you should have idea and you should have gone through the chapter number 7 of your Statistics 1 book. So let's get started with question number 8. Okay, the random variable x is normally distributed with mean, mu, and variance 36. Given that probability of mu minus twice of k less than x less than mu plus twice of k, it is equals to 0.6. This is given. Okay, so part A asks to find the value of k. We need to find the value of k. Okay, so right at first they said what? X is distributed normally with mean. What's the mean? It's mu, right? And the variance is basically what? 36, which is 6 squared, right? Sigma square basically. Okay, so we know the distribution of x. Now they said mu minus twice of k less than x less than mu plus twice of k. Okay, so in this case we need to consider the bell curve of normal distribution. This is very important concept, the bell curve. So let me sketch a bell curve on the right hand side of the solution. Right hand side. So the bell curve is basically like this. It goes up, a symmetrical curve, isn't it? It is a symmetrical curve. Okay, this is a bell curve. So right at the middle of the bell curve, this is the mean, right? This is the what? Mean, mu. Okay, so look, the bell curve is basically symmetrical, right? Since bell curve is symmetrical, so mu minus twice of k and mu plus twice of k, these 2 points are basically equidistant from the mean. If you consider this is mu minus twice of k, this is mu minus twice of k, and then this one would be what? Mu plus twice of k, symmetrical. Okay, so the area between this region is basically how much? 0.6, because the area under the bell curve, it shows us the what? Probability, isn't it? Okay, so the area, this area is basically how much? 0.6. Fine. If it is 0.6, that means the sum of this area and that area will be add up to give what? 0.4 total, right? That means this area, only this area, it's 0.2, right? And that area is also 0.2. Understand? So that means what we can write here is that probability of x less than mu plus twice of k, it is what? It is equals to what we can write? Look, mu plus twice of k. This is mu plus twice of k. So this total area is 0.6, right? 0.6, and this area is 0.2. So total area is 0.8. Make sense? Okay. So now standardize the data. If you standardize, what you will get? Z less than or equal mu plus twice of k minus mu over 6, right? Sigma. This is equals to 0.8. Fine. So what we can write? Probability of z less than or equal twice of k over 6. This is k over 3, this is equal to 0.8. Done. Okay, now we need the value for k over 3, right? So this is the standard value. Okay, you can get the standard value for z using the distribution table that will be given in the formula booklet in the exam. Okay, you can find this out from the formula booklet. Okay, so we need the probability 0.8, right? The probability is 0.8. So where is 0.8 probability? This one, 0.8. Look, either this one or that one. Which one is closest? Definitely 0.84 is the closest, so you can consider 0.84. Okay, the value, like the first column, this first column, it shows the value, the standard values, and the second column, it shows the what? The probabilities. Okay, so what we can do here is that we can write what? Z equals to what? In this case, it is equals to 0.84, or you can use your calculator. If you have a ClassWiz FX991EX calculator, then go to mode and then press 7 and then press inverse normal. Okay, that is, after pressing 7, press 3, that's the inverse normal. So area, how much area we want? We want to have area 0.8, right? And then you don't need to change the standard deviation and the mean. For standard values, since z is the standard value, so mean will be 0 and standard deviation would be 1. It's already given in the system. So press equal, so it will be 0.8416. We can take 0.84. It is exactly up to 2 decimal place 0.84. So the value for k over 3, it's what? K over 3, it is equals to 0.84, right? So the value for k is what? The value for k is 3 times 0.84, 3 times 0.84 would give you 2.52. The value for k is 2.52, up to 3 significant figures. That's it. That's the answer for part A, and that's the value of k. Done. Next, the random variable y, it's a different random variable, is normally distributed. It is also normally distributed with mean mu and standard deviation sigma. Okay, given that 2 mu equals to 3 sigma squared and probability of y greater than or equal 3 over 2 mu, it is equals to 0.068668. Okay, so now the question asks in part B to find the value of mu and the value of sigma. We need to find out the value of mu and the value of sigma. So consider the distribution of y. How is y distributed? Y is distributed normally with mean mu, and the sigma is basically the variance. Sorry, sigma square is the variance. Yeah, sigma is the standard deviation, so sigma square is the variance, right? Now they have given probability of y greater than or equal what? Probability of y greater than 3 over 2 mu. Okay, this is just greater than 3 over 2 mu. This is equals to how much? 0.0668. Fine. Okay, now we need to standardize the data, right? So probability of z greater than or equal what? 3 over 2 mu minus mu over the sigma, right? The standard deviation, this is equals what? 0.0668. Fine. Okay, so since it's greater than or equal, we can consider less than or equal, right? Less than, if you consider probability of z less than or equal 3 over 2 minus 1, this is what? Half. So this will be 0.5 mu over sigma, right? This is equals to what? What it would be? 1 minus 0.0668. 0.668. This is because if I show you using a bell curve again, just a sketch, fast sketch there. So less than, greater than or equal 3/2 mu, right? Greater than or equal 3/2 mu, it is what? 3/2 mu is what? It's greater than mu, right? That means if this is the mu, then 3/2 mu would be here, right? Okay. So greater than that, that means this area. This area is given as 0.0668, right? So less than that area would be, the total area is 1, so 1 minus what? 0.0668. Okay? So look, what we can write, probability of Z less than or equal 0.5 mu over sigma, this is equals to 1 minus 0.668 is what? 1 minus 0.0668. This is basically 0.9332. 0.9332. Okay? Okay. So now let's move on to the the normal distribution table, from where we need to take the value for 0.9332, the standard value corresponding to the probability 0.9332. Where is it? Yes, here you go. It is 1.50. Okay, it is 1.50. So it will be what? 1.50. That means the corresponding value for Z, it's what? 0.5 mu over sigma. This is equals to how much? 1.50, right? And it's positive because you can see from the bell curve, right? It lies on the positive axis, because mu, for standard data, mu is basically what? 0, right? Okay, mu is basically 0 because when you standardize, we subtract the population mean. We subtract the mu. Mu is the population mean. Okay, so half of mu over sigma. We know that it's given in the question that 2 mu equals to 3 sigma squared. So that means mu can be written as 3/2 sigma squared, right? Mu can be written as 3. Mu equals to what? 3/2 sigma squared. So what we can write? 0.5 times 1.5. This is 3/2 sigma squared over sigma. This is equals to 1.50. Okay. Okay. So sigma cancels out from numerator and the denominator. So you'll get 0.5 times 1.5. It gives you 3/4. So 3/4 sigma. This is equals to 1.50. Okay. So we need the value for sigma. So sigma would be what? 1.50 over 0.75, which is 2. The value for sigma is what? 2. Okay. The value for sigma we got, this is 2. Okay. Done. Next is we need the value for mu. Since the question asked for the value for mu also, mu is the mean. So mean equals to what? Mu equals to 3/2 sigma square. So 3/2 times sigma square is what? 4. So that would give you what? 6. The value for the mu is what? 6. So sigma is 2. The value for mu is 6. And that's what the question has asked for, and we found it. So this was the last question, that is question number 8 from Statistics S1 January 2024 paper. And yeah, that was all. I tried to explain as much as possible. Like if you have any problem in any of the part of any of these videos in this playlist, then feel free to write in the comment box. I'll be there to reply to you. Thank you.